All right, so where are the stars? It all boils down to sensitivity of the camera, and I'm hoping that this video can help us clarify what the sensitivity actually is. So any old camera consists of many components. Two of the most important ones, the ones that we're going to focus on, are the lens of the camera and then the image sensor. So if we were looking at the camera, this is our eyeball, some eyelashes. Looking directly at it, we would see through the lens and we would see an image sensor which will appear as a grid. Each little cell in this grid is called a pixel. Someone says that it's a 12 megapixel camera. That means that there are 12 million of these little light sensors. So let's exaggerate for the sake of understanding the principle of how the image sensor works. I'm going to magnify the size of these pixels and imagine that there are two objects placed in front of the camera, a really bright one and then a dimmer one. They shine through the lens and onto the image sensor over here. So here's a large bright object, and here is a tiny dim one over here. The distant stars we're all talking about and wondering, where are they? The intensity of the light can be measured in the amount of photons that hit these sensors. So let's say that this large object, be it the moon, let's say, emits 4,000 photons, which means that this sensor sees 1,000, this one sees about 1,000, this one sees 1,000, and this one sees 1,000. And that is all grossly approximated. Now this distant star only has very few photons that reach the image sensor because it's so far away. So let's say the image sensor only sees 10 photons. In the brains of the camera, the computer, when it's analyzing how many photons are hitting each pixel, says, okay, disregard everything that is less than 100 photons. Then this brain of the camera, the central processing unit, asks each cell, what do you see? So this is cell 1, 2, 3, 4, or pixel. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And the resulting image is then either stored in the memory or projected onto display. And let's just imagine that our display has same number of pixels as the image sensor. So when the brain asks, hey, pixel number 1, do you see anything? Obviously there are 0 photons striking this pixel, so it's going to say no. So the the CPU is going to paint this pixel of the display black. 2, nothing. 3, nothing. 4, nothing. Pixel number 5, do you see anything? Yep, I'm getting hit with 1,000 photons. Okay, so it's going to be like a bright red. Pixel number 6, anything? Yep, I got 1,000 photons striking me. Number 7, nothing. Number 8, do you see any photons? Yes, I am seeing 10 photons hitting me. Well, it doesn't matter because 10 is less than 100, so we're just going to disregard that signal and paint the display pixel black. Number 9 sees 1,000 photons. Number 10, 1,000. And then the rest of them have nothing in their way, so we're going to paint them pitch black as if nothing is even there. And the resulting image will look something like this. You will be able to see the bright shiny object, but because the signal from a dimmer object is so faint that the CPU will not project anything onto the display. So I hope that helps with the understanding of exposure.